First of all, we don't deal with defragmentation or fragmentation. We have a single packet that stores the all of the votes that we have. So we ensure that votes or transaction data basically, we have enough of them that they fit one packet, one UDP packet, or the MTU. So yeah, so we put everything in one packet, and we send this whole packet directly to the other nodes of the network. That's one of the things we do to have really fast communication. The other thing is that when we're reading stuff from the network, from UDP, what you might see usually is your kernel dropping the packets because there are too many coming. And since it's UDP, the kernel thinks, okay, it's allowed for me to just drop them if I can't fit them in my buffers. So what we do there instead, we use some kernel functions that allows to draw multiple messages from the kernel buffer. I think it's specifically 32. And we store them we store these messages into some buffers that were pre-allocated, and we don't copy this information again. We immediately process it in that. So we have a zero allocation, zero copy scheme for this, because we want to remove as much messages as we can as fast as possible from the network. And after this happens, we immediately send it to some other worker to decode this information. So we immediately start pulling the next 32 batch of packets, or the batch of the 32 packets. One more thing I want to mention here is that we transfer information as raw bits, basically just bytes of data. We don't use any JSON serialization or anything like that. So it's just raw data being transferred through UDP packets. It's the cheapest and simplest approach that you can take.